Hello, my dear students. Today we are going to continue chapter 5, which is organic chemistry. We are going to discuss the hydrocarbons, and we are going to discuss today the alkenes or olefins. We are going to discuss their preparation and their physical properties and the chemical properties, and we are going to discuss ethylene and its reactions. So let us start. Alkenes. The nomenclature of alkenes. The name of alkene is according to the longest continuous chain as alkanes, but putting the suffix ene preceded by number of carbon atom near to the double bond. As shown on the screen, CH3CH double bond CH2, its name is propene as having 3 carbon atoms and 1 double bond. Next example, here are going to explain the longest continuous chain, which is 5 carbon atoms, and we have double bond between the carbon number 2 and carbon number 3, and so the name of the molecule will be 2-pentene, as the number of the double bond or the position of the double bond is related to the lowest number between the carbon atoms that has the double bond. The next point for the nomenclature, numbering the carbon chain starts from the nearest side to the double bond regardless to the position of the other groups. For example, as shown on the screen, CH2 double bond, CH, H3 all 2. If we are going to numbering the carbon atom nearest to the double bond, and so it will be number 1. So, and the branches here is methyl group at carbon number 3. So, its name it will be 3-methyl-1-butene. Next example here, as shown on the screen, the double bond at carbon number 1, and here we have a branch at carbon number 4 chlorine atom. So its name it will be 4-chloro-1-butene. Now we are going to discuss ethylene or ethene that has molecular formula C2H4. The preparation of ethylene in lab. By removing water from ethanol C2H5OH using hot concentrated sulfuric acid at 180 degrees Celsius, as the following animation show. As shown on the screen, here we put concentrated sulfuric acid and ethanol. We are going to heat till temperature reaches 180 degrees. So ethanol is produced and passed over sodium hydroxide and collected above water, and we are going to collect the jar filled by ethylene gas to show its properties. As shown on the screen now, here the thermometer and the concentrated sulfuric acid and the ethanol, and the prepared ethanol passed over sodium hydroxide solution and collected above water as it is insoluble in water. So the dehydration reaction of ethanol to give ethylene has the following equation: C2H5OH, concentrated sulfuric acid at 180, it gives ethylene and water. So the reaction steps as following. Here, ethanol plus sulfuric acid at 80 degrees Celsius first, it gives ethyl hydrogen sulfate and water is produced. Then the second step, the thermal decomposition takes place for ethyl hydrogen sulfate to give ethylene and releases sulfuric acid again. Now we are going to discuss the physical properties of ethylene or alkene. The first members of alkenes are gases, while from C5 till C15 are liquids, and over 15 are carbon atoms, are solids. And all alkenes are nonpolar compounds and insoluble in water, but dissolve in organic solvent as benzene. Now we are going to discuss the chemical properties of ethylene. The burning. Here, when burning ethylene and oxygen gas is used for burning, it gives carbon dioxide and water, as all organic compounds, when they are burned, combine with oxygen, giving carbon dioxide and water, releasing large amount of energy. The second type of reaction here is addition reaction. The pi bond is broken down and saturated compound is formed. The first type of addition reaction of alkenes and of ethylene especially is the hydrogenation reaction. When adding hydrogen to ethylene or ethene, the pi bond is broken and saturated compound is formed, and here it will be ethane. This takes place in the presence of catalyst nickel or platinum at 150 degrees till 300 degrees Celsius as shown on the screen. Here, my dear students, the unsaturated vegetable oils as maize oil contain double bond, so is broken down on hydrogenation and turns to solid artificial fats. The next type of addition reaction of ethylene is halogenation reaction. When bromine solution, which is bromine dissolved in carbon tetrachloride, is added to alkene, the red color of bromine is removed, indicating the presence of pi bond which characterize the alkene, as the following animation show. As shown on the screen, one of the tubes contain alkene and the other tubes contain alkane. When we adding bromine dissolved in carbon tetrachloride that we call bromine solution in alkane, the brown color of bromine remains, while when going to put the bromine water on the second tube that contains alkene molecule, we are going to show that the double bond will be broken, and so the bromine is added to the two carbon atoms, and so the red color of bromine will be removed as shown now on the screen. Now the red color is removed, indicating that the pi bond is broken down and saturated compound is formed as shown on the screen. Here the equation of the reaction: when adding bromine to ethylene, the pi bond is broken and forms 1,2-dibromoethane as shown on the screen. The next reaction of ethene is the reaction with hydrogen halide, hydrogen chloride or hydrogen bromide or hydrogen iodide, as the following reaction will show. But first, my dear student, we have to define there are two types of alkenes: symmetric alkenes and unsymmetric alkenes. What is the difference between symmetric alkenes and unsymmetric alkenes? As shown on the screen, the symmetric alkenes are alkenes where the double bond between two carbon atoms having equal number of hydrogen atoms, as in ethylene, CH2 double bond CH2, the two carbon atoms have equal number of hydrogen atoms where the double bond present between them. So in adding hydrogen bromide, the pi bond is broken and the hydrogen atom is added to one carbon and bromine atom is added to the other carbon, forming bromoethane or ethyl bromide as shown on the screen. My dear student, the second type of alkene, which is unsymmetric alkenes, here the alkene, the double bond between two carbon atoms having unequal number of hydrogen atoms, as shown in the example propene. Here the double bond between two carbon, one contain two hydrogen atom and the other contain one hydrogen atom. So it is unsymmetric alkene. So on adding hydrogen halide to this unsymmetric alkene, we have to obey Markovnikov rule. This rule states that on adding asymmetric reagent as halogen acid or sulfuric acid to unsymmetric double bond, we find that the positive part of the reagent, which is H positive ion, is added to the carbon atom that rich in hydrogen, while the negative part, which is the halogen or OSO3H radical, is added to the carbon atom poor in hydrogen. So the equation of the propene or propylene with hydrogen bromide, on adding the hydrogen bromide, the pi bond is broken down, and so we have to add the hydrogen to the carbon rich in hydrogen and the bromine to the carbon poor in hydrogen. So it forms 2-bromopropane. We have given reason in this point, my dear students. 1-bromobutane is not formed on adding HBr to 1-butene. The reason for that, because according to Markovnikov rule, on adding a symmetric reagent to unsymmetric double bond, we find that the positive part of the reagent, which is H positive ion, is added to the carbon atom rich in hydrogen, while the negative part, which is bromide ion negative, is added to the carbon atom poor in hydrogen. So as the equation proceeds on the screen, 1-butene, on adding HBr on it, we have to add the bromine atom to the carbon poor in hydrogen. So it forms 2-bromobutane as shown on the screen. Another give reason in this point. Markovnikov rule is not applied on adding HBr to 2-butene, because 2-butene has symmetric double bond. So the hydrogen atom of HBr is added to any carbon atom of the double bond. As shown on the screen, 2-butene plus HBr, it gives 2-bromobutane as shown on the screen. Now we are going to discuss the next reaction, which is the addition of water. The addition of water to alkene is called catalytic hydration of alkene. So the catalytic hydration of ethylene or ethene, here the water is weak electrolyte, so concentration of hydrogen ion is very weak and cannot break the double bond between the two carbon atoms. Therefore, the reaction occurs in the presence of a strong acidic medium to increase the concentration of hydrogen ion. So the reaction as shown on the screen, ethylene C2H4 plus water at temperature 800 till 110 degree in the presence of concentrated sulfuric acid, it gives ethanol C2H5OH. This reaction takes place via two steps. The first step is adding sulfuric acid to ethylene at 80 degrees Celsius, it gives ethyl hydrogen sulfate. Then the ethyl hydrogen sulfate is hydrolyzed, so it gives ethanol and sulfuric acid as shown on the screen. Here, my dear student, so ethyl hydrogen sulfate can take place via two processes. Here, if thermal decomposition, it gives the ethylene, while on hydrolysis, it gives ethanol as shown on the screen. The Next type of reaction here is the oxidation reaction. Here we are going to define what do we mean by Bayer's reaction. Bayer reaction is adding dilute potassium permanganate, which in alkaline medium, to ethylene, giving ethylene glycol, which is dihydroxy compound, as the following animation show. Here, my dear student, we use the potassium permanganate, which is an alkaline medium, added to the ethylene or ethene. We find that here the ethylene glycol is produced, and here we find that the potassium permanganate, its violet color is removed, and so the violet color removed indicating that the presence of alkene here, so it tests for the pi bond or unsaturation of alkene. As the equation proceeds on the screen, ethylene plus water plus atomic oxygen produced from potassium permanganate, it gives ethylene glycol, which is dihydroxy compound as shown on the screen. So we have good reason in this point. Bayer's reaction is used to test for double bond or unsaturation because the violet color of potassium permanganate is removed. My dear student, notice that hydrogen peroxide H2O2 can be used also for oxidation of ethylene, giving ethylene glycol, but it can't be used to test for the unsaturation because no color change will take place appearing to the eye. As the equation proceeds on the screen, ethylene plus hydrogen peroxide, it gives also ethylene glycol. We have good reason in this point also. Ethylene glycol is used as antifreeze substance in car radiator in cold countries because it forms hydrogen bond with water molecules, preventing their combination with each other, forming ice crystals. The next point we are going to discuss, my dear student, is the polymerization reaction. The polymerization reaction, it is the joining of small chain unsaturated hydrocarbons monomers, giving long chain hydrocarbon, which is polymer, with the same empirical formula. And there are two types of polymerization reactions. Addition polymerization. This addition polymerization takes place by adding a huge number of unsaturated small molecules to each other to form a very large molecule, such as the formation of polyethylene, which their number ranges from 100 to million, as the animation shows. Here, my dear student, we have two molecules of ethylene, and on polymerization, the joining by breaking the pi bond, and so the two molecules join with each other, and more molecules of ethylene will break the pi bonds to form the huge number of polymer that is formed by addition polymerization, as shown in the following screen. So the equation of polymerization of ethylene is done that on heating ethene under high pressure, about 1000 atmospheric pressure, in the presence of peroxide as initiator, we find that the ethylene, by presence of catalyst and pressure, it gives polyethylene. The second type of polymerization here is condensation polymerization. It takes place between two different monomers that lose a simple molecule as water. That on joining and in produced copolymer is the basic unit for polymerization process. So my dear student, the condensation process takes place via formation of copolymer first, then the copolymers join to each other to form the polymer. So happens in two steps. Now, my dear student, we are going to discuss different types of addition polymerization of different monomers. Here is the monomer and the polymer and the commercial name of the polymer. Here, ethylene, the polymer produced from it is polyethylene or polyethene, and its commercial name is polyethylene. And its property is soft, tolerate the effect of chemicals, and it is used in plastic sheets, bags, bottles, and hoses. The second monomer we are going to talk about it is propene. Here, the polymer produced as shown on the screen, it will be polypropylene, and its commercial name is polypropylene also. And its property, it is hard and rigid and is used in carpets, cases, and cans. The next monomer for alkene, here we are going to discuss chloroethene or vinyl chloride. My dear student, when ethylene, one hydrogen atom is removed from it, it will be radical called vinyl radicals. So, vinyl attached to chlorine is called vinyl chloride. The polymer produced as shown on the screen, it will be polychloroethane. And its commercial name, polyvinyl chloride or PVC. Its property is rigid, hard, or soft. It uses drainage tubes, plastic tubes, shoes, hoses, electric wires, insulators, and oil bottles. The next monomer, my dear student, is shown on the screen, tetrafluoroethene, and here we will find that the polymer produced is tetrafluoroethene, polytetrafluoroethene, and its commercial name is Teflon, and its property, it is resisting heat and adhesion and electrical insulator and is inert substance. So it's used in cooking utensils and surgical threads. So we are going to discuss some questions. Choose the correct answer. The number of hydrogen atoms in alkene having 5 carbon atoms is what? 5 or 14 or 10 or 12? If you think about it, yes, it will be 10 if you apply the general molecular formula CnH2n. Next point, the number of carbon atoms in alkene having 12 hydrogen atoms is what? If you think about it, my dear student, yes, it will be 6. Next point, the molecular formula of an alkene having 10 hydrogen atoms is what? Is it C5H12, C5H10, C5H14, C5H8? If you think about it, yes, it will be C5H10. Next point, PVC is produced from the polymerization of what? Tetrafluoroethene, vinyl chloride, propene, and ethene. If you think about it, yes, it will be vinyl chloride. The number of sigma bonds between carbon and the hydrogen atom in an alkene having 3 carbon atoms is what? 4 or 8 or 10 or 6? If you think about it, yes, it will be 6. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.